formula. Look at this. This is kind of a new thing for this unit. R is the radius of orbit from the center of each object. Okay, we kind of already knew that because we know we need to go from the center of Earth and include Earth's radius. But then here's kind of a new term. Here's a new term. The orbital radius means from the center of each object. So if a question gives you the orbital radius, that includes like Earth's radius or the planet's radius. So you don't have to do like RT plus RD, etc. if you're given this. So this is the full, you would think this is like how we've been talking about it, this would be RT. You don't have to do anything else to it. So that being said, let's look at this second example. A planet is orbiting a star with an orbital radius of 9.72 times 10 to the 9 meters. So we know that that's R. That's the R we get to use in our formula. It takes the planet 7.6 days to make one orbit around the star, okay? So we can say that T takes 7.60 days because that's per one orbit. What is the mass of this star? So that's M2. Because the star is like the central focus point. If we read this, it says a planet is orbiting the star. So planet is M1, star is M2, because it's creating that gravitational field strength. Okay, so before we launch into putting this into our formula, we need to do something to our period. We need to convert it into hours. Okay? I mean seconds. Thank you. Yes. So again, we set up our fraction. So we want to let's put it in first to hours. How many days, or how many hours in one day? 24 hours in one day. So we cross off days, and now we have our units in hours. Well, next, I can multiply by a fraction with hours on the bottom, because I want it to be able to cross off. And I would preferably like to end up with seconds, and I know I can do that in one step. So how many seconds in 1 hour? We just discussed that, 3,600 in 1 hour. So what you actually put into your calculator is T, well, no, you don't put T into your calculator. You put 7.6 multiplied by 24 multiplied by 3,600. Because they're all on the top fraction, which makes sense because we're going from days into seconds. So we need a really big number. So the T we use in our formula is 656,640 seconds. So yeah, I would do that first, kind of make sure all of your units are okay before you kind of get too excited. I know that this is very exciting, so just take your time. Okay, that was a joke. So FC, actually I think this is kind of exciting. I should get a little solar system model for us to conceptualize this stuff, though. That would probably help a little bit. So our FC is equal to FG, always for planets. Okay, so let's think about it. We need to have an FC that includes our T, right? So I'm going to use my AC formula that has my T in it. So M1 times 4 pi squared R over T squared is equal to big G times M1 M2 over R squared. Generally, for your FG, you'll use this one. The only time when you don't is when you're actually given your gravitational field strength. Cross off our M1s and cross multiply. So I have 4 pi squared times by R cubed is equal to G times M2 over T times T squared. So I'm solving now for M2. That was my whole question at the beginning.
So knowing that r squared cubed, r cubed is proportional to t squared, does that change anything?
For mathematically? No, it's just to understand the concept of it. And that we can see that Newton took Kepler's information and built on it. And could actually prove it. Because Kepler just basically said, okay, the radius, the distance and the period are proportional to each other. But Newton did a lot more astronomy studies, and so we can really see it clearly mathematically. But so you just need to know that they're the theory, the concept of it. Yeah. Okay, so solve for M2. So we'll divide by g and t squared. So M2 then is 4 pi squared times by 9.72 times 10 to the 9 meters. That's all cubed. All divided by 6.5664 times 10 to the 5 seconds, which that is squared, times by 6.67 times 10 to the negative 11. So I would be very careful putting this into your calculator. Make sure that you've got brackets around, like if you do all this and then press enter, make sure you got all of this in brackets when you divide by. Got an answer?
He does.
What do you got, Kim? Really? Try again. Somebody else get an answer? Make sure you do it right now in your calculator. See what you get, because there's a lot of clicking that needs to be done. Okay, what'd you get?
Is it 1.26 numbers times 1.3?
Yes.
I got 4.1.
Okay, let's do some calculator punching.